All right, so we're going to talk about inverses, kind of what properties have to be, what properties it has to conform to be an invertible function. We're going to look at it graphically. We're going to look at it through a table, and we're also going to look at it algebraically. So let's just start with a regular old graph. So I'm going to start with a graph of a parabola. So here is a graph of a parabola. For a function to be invertible, or to be able to take the inverse, it must be 1-to-1 and onto. Now, for high school, we're going to assume all functions are onto. We're not going to mess with that in high school. But we are going to have to worry about this 1-to-1 function. Now, the first thing you have to look at is you need to make sure it's a function first and foremost. And if you have a graph, the easy way to tell if it's a function is just simply imagine a vertical line everywhere. And if it only touches one spot, it's a function. And in this case, my x squared is a function. Now, the 1-to-1 function means that for every single x, there can only be one y. So the y values can't repeat. So we have another type of test for that, and that's a horizontal line test. So if I picture a horizontal line going through this, it's only allowed to touch it once as well. If it touches it in more than one place, then it's no longer an invertible function. And we can see that x squared, if I would draw a horizontal line, is going to touch in two places, and that's a bit of a problem because now at that point, we cannot take the inverse of x squared. But in math, we have a little trick. And I'm going to show you the trick here is we're going to do what we call, we're going to cut this function. We're going to pretend, we're going to ignore all of this part right here. And we're going to say that my x squared, and I want to restrict the domain, we're going to say x has got to be greater than or equal to 0. So now we're only looking at this part of x squared. Now if I draw a horizontal line, it passes. So now x squared is invertible, but I had to restrict the domain. Now there's another way I could have restricted the domain. I could have forgot about the positive side and could have come to the negative side, and I'll show you how we can deal with that later. Now, so now that x squared is invertible, let's see what the graph would look like of the inverse. Well, the graph of the inverse, we are going to reflect it over the line y equals x. So this is y equals x. We're going to reflect it over that line. And what we're going to get is something that will look like this. So that's the inverse. It's a reflection over y equals x. So we're just reflecting it. Boom. And in fact, I'm going to show you algebraically what the equation of that is. So easy enough. For a function to be invertible, it must be 1-to-1 and onto. We're going to assume everything in high school is onto. So we're just going to have to check to see if it's 1-to-1. If it's 1-to-1, we don't have to do anything to it. And there are functions that are 1-to-1, like x cubed or y equals x. That's a 1-to-1 function as well. Most anything linear, anything that's going to be like x cubed or things along those lines. These x squareds, x to the fourth, they are not 1-to-1, so we are going to have to find a way to restrict the domain. Later on next semester, we'll have to restrict the domain of trig functions of our sine and cosine, so we can actually find the inverse of sine and cosine, and that's a whole nother kit and caboodle. All right, so now we have the graph of x squared when x is greater than or equal to 0. That allows it to be 1-to-1. We have the graph of the inverse, and this is going to be f inverse of x if we say that this is f of x. But we don't know this equation yet. We don't even know the domain of this yet, or we don't even know the range of this yet. So let's play a little game. Let's make a table of f of x. So this is going to be for f of x. So I want to make a table of x and y values. Now, all the x values I have to pick has to be greater than or equal to 0. So I could pick any number that's greater than or any positive number, but I get to pick them. So I want to pick easy numbers to do math with. So I want to pick like 4 or 5 numbers. So I want to pick 0, 1, 2, 3, 4. Those are all easy to do math with. Find the y value. I'm just going to plug it into my x squared, and I want to get 0, and 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now here's what's really, really cool about this. If you remember from Algebra 2, if you have the table of f of x, you have the table of the inverse. Because all you do is you swap your x and your y's, because the domain and range interchange with inverses. So this becomes 0, 0. You can't tell there, 1, 1. But now here, I've got 4 and 2, 9 and 3, 16 and 4. Hopefully this is all just a review for you. Now, I have a table of inverses. My x's and y's, I just switch them. I have the graphs. Let's look at the general rule on how to find it algebraically. So if I have the equation f of x equals x squared, and I'm not going to worry about the domain quite yet. I'll show you where we'll have to worry about the domain. What I'm going to do is I'm going to change my f of x to y. So I'm going to have y equals x squared. And if you remember from the table here, my x's and y's switch. So I'm going to switch my x and my y here. So I'm now going to do x equals y squared. I'm going to get rid of the square by taking the square root of both sides. Do not forget your plus or minus. Do not forget your plus or minus. Whenever you take a square root to move for the other side, you must have plus or minus the square root of x equals y. So this could potentially be the inverse, but one of these is the inverse and one is not. One's going to be the positive, one's going to be the negative. I'm going to come here and look at my domain restriction. X is greater than or equal to 0, so that means my x has got to be a positive number. Therefore, this inverse is going to be the square root of x, and that makes sense with my table because the square root of 16 is 4, the square root of 9 is 3, the square root of 4 is 2, the square root of 1 is 1, and the square root of 0 is 0. Whereas over here, 0 squared is 0, 1 squared is 1, 2 squared is 4. So it all it all goes together nice and pretty. So in the next video, I'm going to show you how to find the inverse of something a little bit more complicated than just x squared, and show you the different ways that I can kind of throw curveballs at you. But this is the general idea, a review of inverses that you guys did in Algebra 2. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.